Going to sound very similar, but we're focused again on solving one-step equations. And the ongoing theme, sixth grade, remains the same. Isolate the variable. Seems a little redundant after a few days, but it's what we're doing. Once again, looking at some multiplication and division today, the difference is today we'll incorporate some negative numbers, which you can handle. So I'm going to have negative 6x equaling 36. We know that a number right next to a variable means multiplication. So once again, this is a multiplication problem. So all I'm going to do is divide everything by negative 6. Okay? And so I know when I divide that by negative 6, then I get x by itself. Now I can come over here and I can think of this now as being divided by negative 6. I can also think of this as just negative 36 over 6 and just have a negative sign in front of the entire fraction. Either way, I know what I'm doing is 36 divided by 6, but since it's negative, 36 divided by 6 is 6. X is going to equal negative 6. And sure enough, if I go back to my original equation, negative 6x, or negative 6 times x equals 36. It's negative 6 times negative 6. That's equals 36 because a negative multiplied by a negative will be a positive. I go to number 2, 4x equals 20. Pretty straightforward. It's 4 times x. So I'm going to divide everything by 4. That's going to get x by itself. Then I come over here. I have to take the 20 and divide it by 4. 20 divided by 4, I find that x equals 5. And sure enough, I go back to my original equation. It is 4 times 5. That equals 20. So moving this to the side, now we get some division. And most of the time, division will be written as a fraction. X divided by 7 equals negative 27. Now, once again, how do I isolate the variable? I do that by doing the opposite operation. This is division, x divided by 7. So what am I going to do? I'm going to multiply both sides by 7. When I take x divided by 7 and multiply it by 7, that just leaves me with x. So then I come over here and I think, well, I've got to do negative 27 times 7. Now I know when I do a negative multiplied by a positive, it's going to be a negative answer. Okay? So I'm not even going to worry about the negative for the time being. I'm just going to come over here and do 27 times 7 and know that in the end, my answer needs to be negative. 7 times 7 is 49. Put the 9 down, carry the 4. 7 times 2 is 14, plus the 4 is 18. 27 times 7, sure enough, is 189. But since this was actually a negative 27, and it was a negative 27 times 7, I know that x equals negative 189. Okay? Basic math. Just got to remember the signs, doing the right type of math. Once again, you see a division sign. Most of the time you're not going to see that, but you can't really have fractions and mixed numbers within fractions. So when you have a problem with fractions, you really have to use a division sign. So I don't really have a problem with this example in number 4. But the operation remains the same. It's x divided by 2/5. How do I isolate the variable? How do I get x by itself? And x divided by 2/5 equals 3 1/3. Well, I'm going to multiply everything by 2/5. Whatever x divided by 2/5 is, if I multiply whatever that answer is by 2/5, I end up with x. Which is why I have to come over here, because as we've said before, whatever I do to one side of the equation, I have to do to the other. So I'm going to come over here, and I'm going to have 3 1/3, and I'm going to multiply that by 2/5. Now, we know the rules of multiplying fractions. Everything has to become a fraction. 3 times 3 is 9, plus 1 is 10. So that's going to become 10 over 3. And then I'm going to multiply that by 2 over 5. Just remember my rules of multiplying fractions. This is not division, so I'm not flipping the second number. I'm not making the reciprocal. I'm going to look to cross-check. When I look at the 3 and the 2, I'm thinking there's no number besides 1 that can go into both 3 and 2, so I'm going to leave those alone. But when I look at the 10 and the 5, I'm thinking to myself, well, those are both divisible by 5. Sure enough, 10 divided by 5 is 2. 5 divided by 5 is 1. And so now I'm looking at 2 times 2 and 3 times 1. Well, 2 times 2 is 4. 3 times 1 is 3. And I'm double checking 4 over 3 is in simplest form because no number besides 1 can go into both 4 and 3, but it's an improper fraction. And you're going to have to take improper fractions and turn them into mixed numbers. That's not a problem though. I'm just going to do the division problem. 4 divided by 3. 3 can go into 4 one time. If I take 3 into 4 one time, I think I'll have 1 left over. My denominator is going to be 3. 1 1/3. Have a great day, 6th grade. We'll talk to you later.